Hi there, this is Dr. Embody. Right now we're going to take a look at Project 2, which is giving us a little practice with control, how to do a loop, how to do an if, make some choices, and let's dive in and take a look. So what do we have to do in this project? Well, we have to we're going to play around with some distributions. We're going to take three inputs, the mean, a standard deviation, and how many values we're going to look at. And then we're going to print out a bunch of values. And if you look at the sample output, so what are we going to do? We're going to we prompt for a mean, standard deviation, how many values, enter those. We echo them, just print out, yeah, that's what we got. And we have two values here. What's the smallest one that's generated, and what's the biggest one that's generated, and what the actual mean was. So we have a distribution that's around 50. What did we actually get? It's a little bit different than 50. And and how do you do a mean? Well, you add up all the numbers and divide by how many there were. Nothing new and exciting there, except how do we do that in a computer? And so pretty clearly, if I'm going to add up all the values, I have to collect them in something. And so we need a variable for that. I'll call it total. And every time we get a new value, which in the example was called a dist, that was the name that it was, then our total will be our previous total plus whatever that value of dist is, and we keep going around and keep adding on to it. And so I'll take a look at a couple of those things. And then the other thing is we have to count. How many were bigger than two standard deviations, and how many bigger were than one standard deviation? There's the standard deviation. So you take the mean and two of those. So that would be 50 plus 4.6, so 54.6. How many more, how many fit in there? Okay, so those are some of the things that we have to do. And let's take a look at some of that code. So I'm going to start with the sample that we have. And I took out the comments just so I have a little more room to work with here. But I can run this thing. And what does it do? It shows us a bunch of the 5 values. It goes through, prints out, gets 5 values, calling this random Gauss, basically gives us a random number with a Gaussian distribution. And so we get 5 of those numbers, and we print them out, both rounded and not rounded. And if I look at the variable explorer here, we see that value finished up with a value of 4, and the dist is in fact the last value that we see printed down here. So remember, if we have range value, when we have range 5, it starts at 0 and goes up to 4. So that means it does it 5 times. That's what that means. And I could, in fact, take so to play around with this thing here, how many, and how many will be. That's a lousy name. Let's go. I'll call it number. And what is this? This will be int input. How many? How many values? All right. And so what am I going to do with that? Well, instead of the 5 here, let's put my number, and I'll actually ask for some values. Okay, so this time when I run it, if I give it 5, we can see that it prints out 5 values. If I gave it a 10, now if we count those up, yep, there's 10 values there. So there's a way that we can use input to generate how many values there are. If we want to collect things, I need something to collect it in. Because as we're collecting things, we're going to be adding, so we're going to use the additive identity as the starting point, which is 0. And if I want to collect those total values, then what I will do is take my total, which starts at 0, and add on to that the distribution. And we can see by printing at the end here total, and let's see what we get here. So how many values? Let's do 5. Right. And it goes and it adds them up, and it comes out with 473. And we can eyeball this and see, well, let's see, I've got I've got 114 and 79 and 89 and 105 and 84. Yeah, that's, they're all around getting close to 100, and I got 5 of them, so 473. That seems like a reasonable number. I could check it on a calculator. Right? And now, how would I find the average? Well, I just had, what's the total divided by how many values I have, and I can calculate an average. How about finding a minimum? Well, there's a clever thing here. In fact, we don't want to do it that way. How might I find a minimum? Well, one thing I can do is take a stupidly big number. Let's go 10 raised to the 6th power. That's 1,000,000. I'm certainly not going to have any values that are that big. And anytime I find a smaller value, anytime I have a smaller value, which will happen on the very first one, I now have a new minimum. And I can check this. And see what happens. Alright, so again, let's do 5 values. I in fact get the same values because my seed is 0. And this says the minimum was 79. So let's go back and look at them, and there it is, 79.05. That's the minimum. How did it do that? Well, it went through, and the very first time in there, it says, is my dist value, which is 114, is that smaller than the million that I have as my min? And it is. And so right away, my min will be the first value I have, 114. Now the next time through the loop, it will say, we'll have a 79. It will say, is the 79 smaller than my current min, which happens to be 114? And the answer is yes. And so min will now get that 79. Next time through the loop, the dist will be 89. And we'll say, is 89 less than my current min, which is 79? The answer is no. So it won't go and change the min, and we go all the way through this, and we see that that min is the smallest one. So, you start big and you make it smaller. Another way to do it is you can say the first time, it will equal the first value. How about let's do a count of how many of these are bigger than, say, 100. Okay, so I'll call this my 100 count. All right, and we don't have any that are bigger than 100, and so I can, in here, I can say if my dist is bigger than 100, then my 100 count will get 1 bigger. Now I can do this as 100 count plus 1, but I'm lazy. And an equivalent way to do that, and you will get used to doing this, is a plus equals 1, and that says I'm going to take the 100 count and add 1 onto it. And so let's print that out. So how many are bigger than 100? Again, we can run this and test it. And let's see, let's do 5 numbers again. And it says there were 2 that were bigger than 100. And if we look back at my values, there's a 114 and there's a 105. And now I have a count of how many were in the hundreds. What is, and now I can find that as a percent. Okay, so there were 2, and there were 2 out of 5. So I can do a little simple arithmetic that make that into a percent and print it out. So there's a few things to help you get started on this project. Good luck.